Section 5.6, Part 3. More examples of using integration by substitution technique. And our first problem is going to be the integral of x to the 5th minus 3 to the 6th times x to the 4th dx. And I'm going to start us off on this one, and then I'm going to ask you to press pause and see if you can finish it on your own. The thing I'm going to remind us all of in the beginning, and do this very first step for you, is that we're always going to let u equal the inside function. So you're looking for composition, and here we see composition. We see a function raised to the 6th power. Raising to the 6th power, that's the outside function. The inside function is the function that gets raised to the 6th power. So we let u equal x to the 5th minus 3. So that's where I'm going to stop. You continue on, take du, set up the integral, evaluate it, and then press play. I hope you had success there. Let's see. So du is 5x to the 4th dx. And now that we've got some experience with this, we can see that what we want here is 5 times x to the 4th. So in the last problem in the previous exercise, I went inside here and I wrote like 1/4 times 4, and now I need 1/5 times 5. But I'm just going to go ahead and put that 1/5 out front. This is 1/5 the integral of x to the 5th minus 3 raised to the 6th times 5x to the 4th dx. And now, notice, we have u to the 6th power, and then we have exactly du. We just have 1/5 times all that. So this is 1/5 times the integral of u to the 6th du. And we know how to integrate u to the 6th du. I just looked at my own notes, and I apparently don't know how to integrate it. But it is 1/5 times the antiderivative is u to the 7th. I'm going to go ahead and do it like this, divided by 7 plus a constant. So this is 1/5 times 1/7. That's 1/35. And then u to the 7th, we put back in terms of x. So that's x to the 5th minus 3 plus constant. Okay, so more examples. These are taken from even-numbered problems in the book. E to the x cubed minus 3x plus 7 times x squared minus 1 dx. So these are just they're gonna start to look weirder and more different, and I just want to remind you, stand on that let u equal the inside function. Try it. And even if in the beginning you can't see how it's going to work out, write it all down. Use your writing to help you think it through. The inside function here is this function here. So let u equal x cubed minus 3x. what is du? It is 3x squared minus 3 dx. And that is not exactly what we see there. We see just x squared minus 1, but I don't even see, you know, it doesn't appear to be that we're off by just a constant. But when we look at it a little more, I realize, I could factor out a 3 here. If I factor out a 3 times x squared is 3x squared minus 1. So what we have, our du is really 3x squared minus 1 dx. And what we have up here is just x squared minus 1 dx. So we really are back in the same position that we were earlier. We want to see 3 times all this. So I'm going to put a 3 here, and I'm going to put a 1/3 out here. So this is 1/3 times the integral of e to the x cubed minus 3x plus 7. And now I'm going to put my 3 times x squared minus 1 dx. So now we've got it. This is exactly du, and this is e to the u. So this is 1/3 the integral of e to the u du, which is 1/3 e to the u plus a constant, u being x cubed minus, whoops. So I hope you caught my mistake that I only just now caught, but it actually turns out not to have affected anything because I didn't make the same mistake here. I said earlier, I want u to be the inside function, and I didn't complete it. Curious to know if I replay the tape or the recording, if I actually said +7 but didn't write it. Anyway, I didn't write it here. Fortunately, I did write it here. Notice the reason I didn't discover it until the end is because it didn't affect the du, because the derivative of 7 is a constant. So, but I now finally noticed it. This is 1/3 e to the x cubed minus 3x plus 7 plus constant. Okay, another one sort of along the same lines. Evaluate the integral of x squared minus x over 2 x cubed minus 3x squared cubed dx. And I will get us started on the right path. Notice, look for composition. Look for either e to a power or just 1 over. Here we do see 1 over, but we don't see 1 over u. We see, I mean, we don't even see the 1. We would have to factor this out. But we don't see 1 over just, you know, something to the first power. But we do in the denominator see composition. We see a complicated function raised to the 3rd power. Try it. I know it doesn't seem like it's going to work. Try it. You've got to go for it. Let u equal 2x cubed minus 3x x squared. Then, as we say, turn the crank, learn the method. And once you learn the method, you've got to just make yourself go through it. Du is, bring the 3 down, this is 6x squared minus, bring the 2 down, minus 6x dx. And it starts to look a little bit like the previous one, where I can factor this 6 out. And this becomes x squared minus x dx. And you have to be comfortable with fractions. You have to know a over b times c. This is the same thing as these two being multiplied. So x squared minus x times dx, we really do have x squared minus x times dx up here. I just need it times 6. So we do the same thing we've done before. This is 1/6 times the integral of 6 x squared minus x. On the bottom, 2x cubed minus 3x squared cubed dx. And there we have the integral that we wanted to see. We have 1/6, and then we have du, and then we have u cubed. So this is 1/6 the integral of, I don't know where you want to think of this. Let's just put it up here, du over u cubed. Well, we've got u to a power in the denominator here. So let's rewrite this. We can't take the antiderivative yet. We have to first rewrite this as u to the minus 3 du. And now it's written as form A, u to a power du. Okay, so then this is 1/6 times u to the minus 2 over negative 2 plus a constant. These multiply, so this is minus 1/12. U to the negative 2 is 1 over u squared. And now the only thing left to do is to unsubstitute, to go back and put the original formula in terms of x in for u. So the final answer is minus 1/12 times 1 over 2x cubed minus 3x squared plus constant. All right, originally I was going to be done with the lecture right now, and I can either make a short part 4 or I could extend this a little bit further. Let's make a short part 4. So see you soon.